Assalamualaikum, my name is Muhammad AFIF from Group G. Our group members include NABIL Omar, Muhammad Arif Daniel, DANISH IRFAN, and myself. To begin with, I would like to present the first part of our project, which was the analysis that we did on the data given to us based on tablet pill LajakLaku G. Based on 200 samples of data which are randomly taken from LajakLaku tablets produced in December 2021, we have made several analyses on it. We analyze our data in form of tabular and graphical form, and the first analysis that we have made is based on the sum aspects, where we have calculated the sum of weight, sum of relative density, and sum of tensile strength using pivot tables by using Excel software. Then we compare the result based on the evening, morning, and night, which is depending on the shift using pivot chart. And from the result, we can clearly see that morning shift is having the highest production, which proved graphically from the summation of weight for morning shift. On the other hand, the average analysis is similar to the sum analysis, where we have calculated the average of weight, relative density, and tensile strength using pivot table, while we graphically analyze the result using pivot chart based on the data charted. Based on the data charted, we can barely see the difference between the value for each terms. For example, value for average of weight displayed almost similar for all shifts. Lastly, we also make a chart based on pivot table of standard deviation for weight, relative density, as well as tensile strength. From the chart, we can see slightly difference in terms of standard deviation of weight and tensile strength by looking at the height difference of the bar in the chart. However, the value for standard deviation of relative density displayed almost similar values. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Danish and I will be presenting question B. The first and foremost, in question B, the question asks us to collect data and create a frequency table with suitable range of values. So we use goodness of fit test method to solve this type of question. Okay, so first, foremost, what is given from the question? From the question, we can obtain sample mean equal to 350 milligram and sample standard deviation equal to 14 milligram. And the question asks us a significance evidence. So we need to carry out hypothesis testing to give the evidence to support our hypothesis later. Now we do frequency table from the Microsoft Excel and transfer it to our table here with suitable range. As we can see, we use 20 range size for this question. First step in order to carry out hypothesis testing is the hypothesis. In this case, we have two hypotheses, H0 and H1, where H0 X follows normal distribution and H1 X does not follow normal distribution. And then we directly go to step 2, which is test statistic. We just simply use normal distribution formula as stated earlier in the question, that the data is normally distributed, and then we refer Z distribution table from table 3 to obtain the probability. And then we calculate EI value equal to N sample size times probability. Since there are two EI value that is lower than 5, we tend to regroup them. We merge those two groups with the group next to them, like this, and then we only have one group. And then from this value, these three value, we just simply use this formula, OI minus EI squared over EI, and then we sum up all these three value to obtain chi-squared test value equal to 0.9789. And then we go to step 3, which is decision rule. So here the critical point is chi-squared 0.05, 2 equal to 5.9915 when we refer table 6. So the critical chi-squared value is located here, where if the value of chi-squared test higher than critical value, we tend to reject H0, and if the value of chi-squared test lower than chi-squared critical, we tend to accept H0. So since chi-squared test is lower than chi-squared critical, we tend to accept H0. So we can conclude that X follows normal distribution with mean 350 milligram and standard deviation of 14 milligram as required by FDA authority. That's all. Thank you.
Assalamu alaikum warahmatullahi wabarakatuh. My name is Nabil Umar, and I'm going to comment on whether there is any significant difference between table weights from different shifts. To solve this question, one-way analysis of variance, also called as one-way ANOVA analysis, will be used. One-way ANOVA analysis is often used to determine whether there are any statistically significant difference between the mean of 3 or more independent groups. First, we make a hypothesis test, which is shown in the slides. After that, we look at the ANOVA table produced by the Excel function. We assume that each of the population is normally distributed with the same variance. By looking at the summary table, we separate the data according to the shift, which is morning, evening, and night. Using the data collector, phenomena table is produced, and we obtain the source of variation between the groups and within the groups. From this table, we obtain the p-value. We compare the p-value with the selected significant level, which is 0.05. According to our decision rule, we reject nut hypothesis and accept alternative hypothesis if the value is smaller than alpha. However, according to our result, we will accept the nut hypothesis since our p-value is larger than the alpha. Based on the result, we conclude that there is no significant difference table weight for different shift.
Hi, Assalamualaikum. Hello, LajakLaku management. I'm ARIFF Daniel and this group leader. Recently, a batch was found to produce a cluster of tablets that show low relative density values of 68%, 74.3%, and 80.1%. Then, the prediction of tensile strength for those three tablets are calculated by using the regression analysis model to find the predicted value of the tensile strength. Okay, so from the Excel we got this value. Okay, I will explain this to you in a different view later. Okay, for the parameter, test was carried out at 94% confidence and linear regression relationship between the dependent and independent variable. So dependent variable is the tensile strength and the independent variable is relative density. So for the linear equation for the relationship y equals to mx plus c, y is the tensile strength of the pill, m is the gradient of the line to be the ratio, x is the relative density of pill, and c is the interception. Okay, for the Excel analysis for the linear equation coefficient, we obtain the equation of y equals to 0.08089x plus 0.018275, and this is the actual tensile strength against the relative density. As we can see, the predicted tensile strength is in positive linear relationship. Okay, for the Excel value, the intercept value C is 0.0183. Okay, the standard error of estimate for C is 32.95%. The gradient M is 0.0809. The standard error of estimation for M is 0.374%. Okay, so the values are valid since it results in the tensile strength value very near to 0. The relative density value is 0 at 95% confidence. For the predicted tensile strength from linear regression equation, we got at 98% y equals to 5.5195, at 74.3% y equals to 6.0291, at 80.1% y equals to 6.4984. Okay, for the regression statistic summary, regression correlation coefficient R is 0.83828451. This can be concluded that the relationship between the tensile strength and relative density has strong positive relationship, as shown in the graph tensile strength against relative density. As a conclusion, the linear regression model is a valid model to be used to predict the test result of the tensile strength of the pill from the relative density with up to 95% confidence level. I think that's all from us. Thank you for your time and Assalamualaikum.